Okay, so I had a couple kids asking me questions about particular problems, and that's the best way to handle this, guys. If you have a question about the packet, make sure you ask questions, because some of you may have never done probability before, and some of the things are harder than others. In the beginning, it's pretty straightforward. It's stuff you've seen before, perhaps in middle school, perhaps at the end of elementary school, but some of it gets a little complicated. So make sure you email me questions, message me questions through Google Classroom, and I can go through things. I can type it out, or I can work it out on a video like I'm going to do here. A couple people asked about particular questions. When you do ask a question, because the numbers repeat themselves, because they're basically coordinating with lessons. This is page 5 in the packet, number 10. And the problem asks, if you have a cup with a penny, nickel, diamond, quarter, what's the probability that you pick a penny and a nickel? All right, so because order doesn't matter, it's just saying a penny and nickel. It doesn't say penny and then a nickel. It's combinations, okay? So we're going to use the combination formula. Out of 4 coins, we're going to choose 2, all right? All right? And that means that's going to be n factorial over r factorial, n minus r factorial, all right? And those are the formulas. So when I do 4 factorial, all right, on the top, because n is 4, because we have 4 coins, 2 factorial, because r, we're choosing 2 factorial, and then n minus r is 2 factorial. 4 factorial, all right, is 24. 2 factorial is 2, 2 times 2 is 4, 24 divided by 4 is 6. So there's actually only 6 different combinations that we can pick using the 4 coins. It can be in different order, but it's not going to matter. So now I go back. Probability is the favorable outcomes over the total number of outcomes. Well, there's 2 ways we get a favorable outcome. That is a penny and then a nickel, or a nickel and then a penny. Come on. Come on. All right, see you later. Okay, so there's 2 different favorable outcomes. So when we do probability, favorable over total, 2 is the favorable. All right, 6 is the total. 2 over 6 reduces down to 1/3. Now, another problem that people asked me about was similar problem right after this, number 11. In number 11, the problem was, hold on, let me double check. I don't want to get this wrong. All right. Number 11, playing cards numbered 1 through 7 are picked. What is the probability of choosing 1, 2, and 3? Okay. So now we're doing 7, choose 3. Again, we're doing combinations because order doesn't matter. If you have a question about the difference between combinations and permutations, please let me know, and we can go through it. So 7, we're choosing 3. So the 7 goes on top, 7 factorial. Remember, factorial is just n times n minus 1 times ... all the way down to 1. Over 3 factorial, because r is 3, and then 7 minus 3 is 4. All right, 3 factorial over 4 factorial. 7 factorial is 5,040. The numbers go big pretty quick. All right, look for things to cancel out, because otherwise your calculator is going to give you an error message. 3 factorial, 3 times 2 times 1 is 6. 4 factorial, 4 times 3 times 2 is 24. So I end up with 5,040 over 144. 6 times 24 is 144. And that gives me 35. Now the favorable outcomes. Okay, if you want to, you can list them. Okay, 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, 3, 2, 1. That gives us 6. If you want to do that, that's fine. Next one, we're not going to list them because there's a lot of them. All right, so now we're doing 6. Probability is favorable, which is 6, over total, which is 35. 6 over 35 gives the answer about 0.17. Now the last one is number 17. This is on page 6. And it said, in number 17, it says a game at the fair involves ping pong balls numbered 1 through 18. You can win a prize if you correctly choose the 5 numbers that are randomly drawn. What are your chances of winning? Okay, so we have 18 different ping pong balls, and we got to pick the right number on 5 of them. All right, so it's 18, choose 5. 18 factorial over 5 factorial, because that's R, over 13 factorial, because 18 minus 5 is 13. That gives us 8,568. There's a lot of them. This is why we're not going to list them. Okay, so basically to figure out how many different ways we can get the right numbers, realize we have to pick 5 numbers total. All right, so see how I started listing all of them? It's not what we want to do because there's going to be a whole lot of them. All right, so this is what we're going to do instead. We're going to go back and do the fundamental counting principle. All right, how many different ways can we get the first number right? Well, we have 5 of them. Okay, because there's 5 numbers. Now, that means 1's gone. That means we have 4 numbers left. So we have 4 possible choices for a number for the last one. And that number is just going to keep going down. So that gives me 3, 2, and then 1. So there's 5 possible ones that can be picked first for us to win. 4 second, it goes down 1 each time. We're going to multiply those together. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120, and of course 120 times 1 is 120. So the probability that we win is 120 over 8,568, which comes out to be, if I do the math, that 0.014. All right, so those are some examples of some problems that people have asked about. Make sure you do, because if you don't, I can't help you. So please make sure you ask questions as we go through this last week. All right, in preparation for your last quiz. It's not going to be a test. You're done with tests. It's going to be your last quiz on later in this week. All right, be good. Be safe. Take care. Bye.